Today's lesson is called Equivalent Exponential Expressions. So to start, I'd like you to just try the opening exercise. Write each of the following as an equivalent exponential expression with a single base. At this time, pause the video, try these on your own, and then resume the video to go over the answers. Okay, now that you had a chance to try on your own, here are the answers to the opening exercise. In part A, you should have added your exponents and kept the base. This is a review of your exponent rules from 8th grade math. So 2 to the 3rd times 2 to the 5th would be 2 to the 8th. So if you look at it that way, anytime you're multiplying, you should be adding your exponents and keeping your base. So part D should be exactly the same. The only thing you have to watch out for in part D is that first m is m to the first. And so that means when you add your exponents, you should keep your base of m and then add 1 plus 3 to get m to the 4th. For B and C, those are your power to a power rule. So for these, you want to multiply your exponents and keep your base. So 4 times 7 would be 2 to the 28th. And in part C, 9 times 2 is 18, so that'd be x to the 18th. And these rules apply whether you have number bases or variable bases. So now that we've completed the opening exercise, it says we now move into the algebra of exponential expressions. A key part of any work in algebra is manipulating expressions to produce equivalent expressions, ones which have equivalent values. In the opening exercise, you reviewed the most basic property of exponents that allows us to write equivalent exponential expressions. So I want to go exponent property, each one separately. And we're going to start with the first one, which is when you're multiplying. You can see these bases are the same, so I'm going to keep my base, and that means my exponents are going to get added, a plus b. You just did several in the opening exercise. But we now have to be able to go forward using things other than just numbers as our exponents. And we also have to be able to take an expression and work backwards, break it apart into the original exponents it came from. So this exponent property allows us to add the two exponents when we multiply. So that's what we have to keep in the back of our mind. It is important to be able to use exponent rules to rewrite exponential expressions in both directions. So you can see underneath that we're going to do two ways. We're going to go forward and we're going to go backward. In example 1, this is a forward example. It says, consider the expression 3 to the x plus 2 times 3 to the x minus 1. It says, use the exponent property from above to simplify the expression. So let's think about this if it was just numbers. If I had 3 squared times 3 to the first, for example, that would give me 3 to the third. I would keep my base and I would add my exponents. Just because we see variables here instead of numbers in the exponent position does not change the rule. So to do 3 to the x plus 2 times 3 to the x minus 1, we're still following the same rule. We're keeping the base, so the base is still a 3, but we're going to take the exponents, which here happen to be expressions, x plus 2 and x minus 1, and we're going to add them because that's still the rule. We're multiplying, so we keep the base and add the exponents. So this is going to be 3 to the, and then you're going to use your old polynomial skills and combine like terms. We have an x and an x, which would make 2x, and we have a 2 and a negative 1, which would make positive 1. So this would be our answer, 3 to the 2x plus 1. Same exact exponent property rule that we are used to, just having expressions in the exponent position instead. Now, what's going to be more new to you, I would say, would be example 2, where you go backward. So here, we're going to consider the expression 3 to the x plus 2. So I want to write a little bit of note for this one, just so that later when you're trying this on your own, you can remember how we did this. If I'm looking at that exponent of x plus 2, we have to think about what that means. X plus 2 means the exponents were added, right? X plus 2, that's a plus sign in the middle. Obviously, they're not like terms. Those must have been the two exponents. They must have been added together. So since x plus 2 means the exponents were added, we're going to write, so that is the multiplication exponent rule. So now that we've decided that that must have been the exponent rule for multiplying these, we can take 3 to the x plus 2 and break that down, go backwards, and this must have been 3 to the x times 3 squared. And I can check myself because I look at that, I see if I was doing this problem from the start, 3 to the x and 3 squared have the same base, so I would add the exponents and I'd get x plus 2. So that's how I know I broke it apart accordingly. Now you can leave your answer like this, or you could see it written as 3 to the x times whatever 3 squared actually is, which is 9. Okay, so this or this could be your answer. You just have to pay very close attention to the directions. Obviously, if it's multiple choice or something, you'll see the choices there. What I'm really concerned about is this first part, because then I know you can break it apart. So what I'd like you to do next is pause the video and try exercise 1 without me, and then resume the video to go over your answers. Now that you had a chance to try on your own, here are your answers. In part A, you had to multiply these. So when you're multiplying, you're supposed to add your exponents. So we keep our base of 2 and we add up x plus 7 plus 4x minus 3. When we combine our like terms, we get 2 to the 5x plus 4. In part B, I was looking for you to go backwards. Since this is 2 to the x plus 4, we should be able to break that apart. Since it was plus x plus 4, we know that must have come from adding the exponents, which is the multiplication rule. So that means I can take this and break it apart into 2 to the x times 2 to the 4th. Or, of course, that would be the same as writing it as 2 to the x times 16. Now, before we move on to our next rule, exponent rule, I want to talk about what if the bases are not the same. So we're going to change the base of one or more of the exponents so that they have the same base. So it's going to depend on the problem. This actually happens quite often, especially on your Regents exam. So this is a very important skill to have. They want us to explain why the expression 27 times 3 to the x must be equivalent to the expression 3 to the x plus 3. So what we're going to do is we're going to start with what they gave us, 27 times 3 to the x. And as you can tell right now, our bases are not the same. So if that happens, we want to change one or both of them. And in this case, if I look at 27, I know 9 times 3 is 27, but I know 9 can be made from 3 times 3. So 27 is really the same as 3 to the 3rd power. And now this becomes 3 to the 3rd power times 3 to the x. So in this case, I did not have to change both. I was able to just change the one. And now I have two bases that are the same. So that now allows me to rewrite this using the exponent rule for multiplying. When we're multiplying and they have the same base, we add the exponents. So that would be 3 to the 3 plus x. And then to make it identical to what we wanted here, I would just rewrite this as 3 to the x plus 3, because addition is commutative. We can change the order without changing the value. And now I see that they match exactly. So the only other thing we have to do now is explain. So I'm just going to say what I did mathematically. 27 is equal to 3 to the 3rd. So we can substitute that value. So we can substitute that into the expression and then add the exponents. So again, if the bases aren't the same, change one or both of them so that they are, so that you can use the appropriate rule. So now we're going to move on to our second exponent rule that we practiced in the opening exercise, which was raising a power to a power. And if you remember here, we're going to keep our base and multiply our exponents. So similar to what we did before, this exponent property is going to allow us to multiply the two exponents when we raise a power to a power. And I want to do an example of going forward using the rule and taking and going backwards, breaking the expression apart. So we'll start with going forward. We're going to consider the expression 4 to the 5th to the x plus 7th. Use the exponent property from above to simplify the expression. So this is still power to a power. We still use the same rule. In order to do 4 to the 5th raised to the x plus 7, we are using the power to power rule, which says we multiply them. So this is going to be equal to 4 to the 5th times x plus 7. We're going to take our two exponents, 5 and x plus 7, and multiply them. So that's actually going to be an application of the distributive property. So our final answer is going to be 4 to the 5 times x is 5x, and 5 times 7 is 35. So this would be our answer. And we're using the same exponent rule that we're always used to using for power to a power. Keep our base, multiply our exponents. So now we're going to do example 2, which is going backwards. We're going to consider the expression 2 to the 5x. Use exponent rules to write an equivalent form here. We're going to do the same thing we did before, and we are going to see what happened and break it apart. So when I see the exponent here, 5x means the exponents were multiplied. So that is the power to a power rule. Okay, so we're going to do it backwards. If I have 2 to the 5x, that must have come from taking 2 to the 5th and raising that entire thing to the x power. And if I want to check myself, I know the exponent rule when I have power to a power is to multiply them. So looking at the way I wrote it, I would do 5 times x, which would be 2 to the 5x, which is exactly what I started with. So I'd like you to pause the video and try the 2 questions underneath exercise 2, and then resume the video to go over your answers. So now that you had a chance to try on your own, Part A wanted you to go forward. You were taking 3 to the 4x plus 1 and raising it to the third power, which means that's 3, and then in your exponent position, you should have 4x plus 1 in parentheses times 3. When you use the distributive property, that means your final answer is 3 to the 12x plus 3. And then in Part B, you should have gone backwards. When I see 3 is now to an exponent of 2x, the 2 and the x are being multiplied, so that came from the power to a power rule. So I can take 3 to the 2x and think of it as 3 and 2 times x. I broke it apart in case you needed to see it, but that means I'm taking 3 squared and raising it to the x power. Now again, you could technically see that as 9 to the x, but most of the time you're going to see 3 squared and then to the x, because I want to see that you can actually use the property to break it apart correctly. And now to finish up our lesson today, I'd like you to try the closure question by yourself. It says, which expression below is not equivalent? So that's really important. Which one is not equivalent to 25 to the 3x plus 6? So a couple of hints here. Make sure you pay attention to not. Since this is multiple choice, I would maybe consider evaluating each of these choices. And I picked one on purpose where the bases are not necessarily going to be the same in all of these. So you might have to do some work, or you might not, depends on how you approach this problem, and change the base if necessary. At this time, pause the video, try the problem, and resume the video to go over the answer. Okay, for the closure question, which expression below is not equivalent to 25 to the 3x plus 6? So the way I approached this is I went through and I simplified these. In number 1, I'm multiplying, so I add my exponents. That would be 25 to the 3x plus 6. In number 2, I'm raising a power to a power, so I multiply my exponents. I would have to use the distributive property. I would get 25 to the 3x plus 6. In number 3, I have 5 to the 6x plus 12. That does not match the base of my original expression. So you can see what I did on the side. Since this has a plus sign between the 6x and the 12, I know this exponent rule was multiplication. They were added together. So this problem becomes 5 to the 6x times 5 to the 12th. So then I realized that's really the same as 5 to the 6th raised to the x power, right? Because 6 and x were multiplied. That must have been the power to a power rule. And so that my bases would then be the same. 12 is a multiple of 6. 12 is coming from 6 times 2. So I can rewrite that one as 5 to the 6th squared. Now my bases are the same. So I would keep my base, which is 5 to the 6th, and add my exponents, x plus 2. And then I decided to take the 3 out there to make this really 5 squared to the 3 times x plus 2, which would make this 25 to the 3x plus 6, which is identical to what I had. Now, you might have chosen to go the other way. Maybe you took 25 to the 3x plus 6, made 25 5 squared, and worked your way backwards from there. But that's the only choice that really is the most difficult to manipulate. Then when you get to number 4, you've got power to a power again, so you multiply your exponents. 3 times x plus 6 would be 3x plus 18. The original exponent was 3x plus 6, so number 4 is the one that is not equivalent to the original expression. And that concludes our lesson on equivalent exponential expressions.